Welcome to qnawire.
Okay, so part A of this problem is asking us to draw a free body diagram for the following scenario. So this is the floor, and then we have two blocks on the floor, and those are A and B. And then we have an applied force being coming from the left that is acting on block A. So what we want to do is draw two separate free body diagrams for A and B. So let's start off with A first. So of course the applied force is going to be on block A, but we're going to think of it as being applied on the center of mass of block A. Oops, sorry, let's do that in black. And then there may be more forces on block A, but we'll come back to that and we'll start drawing the free body diagram for block B. So the two blocks are in contact, so if there's something coming from the left on A, then A is in turn going to act on block B. So let's call that F subscript AB, because this is a force that's being of block A being applied on block B. However, Newton's third law dictates that every force has an equal and opposite reactive force. So in turn, block A is actually pushing back on block B. So let's call that F of BA. The last thing this problem wanted to do was for us to just explicitly state which pairs of forces come from Newton's third law. And as I just mentioned, in equation form, F of BA is going to be equal to negative F of AB. So that's all the forces. So that wraps up part A. So part B is asking us if the magnitude of vector F needs to be, if it's less than the total weight of the two carts, will it still cause the crates to move? This is a trick question because we're told that this is a frictionless surface. So no matter how lightly we press on the two blocks, they will always move, even if it's just an ever so slight amount. So the explicit answer to this question, because of the way they worded it, yes, it will always cause the blocks to move. So maybe just to justify that, because it is a frictionless surface. All right, and that concludes this problem.